Okay, let's go for section 4, stresses, erosion, and bush chains. Anyway, typically, again, this is the mechanical drawing on the sections of the roller chains. Anyway, we have a diameters of the bush, things like that. Okay, and then D1 and D2 is going to be diameters of the pin. Okay, and then we have F over 2 at the top, and then in the plate is F over 2 again, and then the length over is P3, things like that. For the top wheel, okay, we're gonna have a D1, gonna be the diameters of the butch, okay, and D is gonna be diameters of the pin respectively. We're gonna have F over 2, things like that. Okay, therefore, the stresses induced gonna be in four categories anyway. The first one is gonna be bearing stress. Is gonna be at the chain spin. Okay, F over AA is gonna projected area is D2 times B3. Okay, and then for the bending stress, of course, on the pin is gonna F sub F times T over to Z. Okay, Z is gonna be the cross section modulus. Okay, and the shearing stress induced at the chain pin again gonna be double shear, gonna be F over 2 times A over A sub S, things like that. Okay, A sub S gonna be cross section area, things like that. And then the tension stress induced at the chain plate is the area here is gonna be the leftover areas of the chains, things like that, of the plate. Okay, and then the standard of the Lolo chains. Let me read it out for you guys here. Okay, you said here Lolo chains have been standardized by the International Standard Organization or ISO. The ISO standards has combined the sizes of the Lolo chain as standard by both American National Standards Institute or ANSYS and British Standards Institute of BSI standards, respectively. The abbreviation is A is stand for ANSYS and B is stand for the British system, respectively. And then, therefore, okay, sizes, okay, of the Lolo chains are typically expressed in two-digit figure, represented the chain's pitch P in 1 over 16 inch, then followed by the letter A or B. Consequently, the last figure 1, 2, or 3 is presented in order to express as the number of chain strand. For instance, 1 for single strand, 2 for double strand, and 3 for triple strand respectively. Okay? For example, okay, if we get the code of ISO R06 16B-2, it means the little chains have a pitch of 16 over 16. It's 1 inch. It's going to be 25.4 in pitch. With the B stand for the business standard, and 2 stand for the upper stand respectively. Okay. Table 2.1 represent the mass per unit length. Okay, the table here classified by two sides. The left side is going to be British standard, and the right side is going to be the American standard. Okay, this is the weight of the chain in per meters anyway. Okay, and 2.2 is going to be minimum tensile force F sub B. Let me explain. F sub B is mean they guarantee that the chains, if you make a selection of the standard chains, things like that, the chain can be able to withstand at least the F sub B appears in this table anyway. For instance, if you make a selection of the chain 05B, things like that, with one stand, you gonna be guaranteed that you can be able your chains can be able to just take a tensile force at least 4.151, things like that. So therefore, when we design it, okay, we can pick up the right tensile force that what we got on the chain, things like that, to be just used for support, those kind of stresses, those kind of force induced in the system, things like that. Okay, and then the design of the low chain, typically we're gonna do for the feature of three categories. Number one is gonna be we got to know about transmitted power, the pinion and sprocket speed, secondly, and third gonna be transmission feature, like a power input and driven load respectively. Let's go for the first one. Determine the number of pinion teeth. Okay, pinion is gonna be the driving sprocket. Okay, it's recommended to be like this. The number of the little chain should be even number, and the number of the pin and teeth should be odd number. Okay, to make a uniform variance, and like things like that. And number two, the number of pin and teeth should be at least 17 for a uniform smooth drive. But for a shock drive, things like that, we're gonna get at least 23. Okay, we got one system already. We got spaghetti designs already. We pick up for this anyway. And then the heat treatments of the hotness of the roller chain, things like that, to be HV10, 5 to 50 hotness in scale nails, effectively for the pinion. Okay, and then safety fact, service factor, like in the belt design. Okay, we can determine N sub as from table 2.3 up to 2.5 respectively. We can show you up later. And then the speed ratio can be able to determine from N1 over N2 the speed of the high speed shaft over the low speed shaft, things like that. The high speed should be the driving shaft, and then the driven shaft should be sprocket, things like that, most of the time. So let's go for table 2.3 for the smooth drive system. Okay, and the types of driven loads is going to be something like fluid and semi-fluid mixture. So it's why it's every uniform, things like that. On the left hand side, we're going to go for the British system, and the right hand side, we go for the American system. You may figure out the first column there is going to be the number of teeth. Okay, just run from 11 up to 25. You can make a selection on the diving pinion, things like that. And the drivers type of driver is going to smooth, moderate shock, and heavy shock. And then you're going to use with the figure 2-12 after this anyway. So let's see for the driver. Smooth is mean electrical motor, as you guys studied before in electrical engineering course, things like that. So electrical motor typically is very smooth drive, things like that. Okay, we just open the and we got close the circuit, and the motor gonna run. Okay, with the constant voltage, constant current, things like that. So everything gonna run smoothly. And then for the moderate shock, it's gonna be multiple cylinder of IC. It's gonna balance to each other. Like for instance, like one cylinder is going up, the other cylinder gonna going down, things like that. It's gonna be balanced almost of the time. But for the shock load, things like that, we got single cylinder. Okay, it's gonna go up and down only, so that's why it's gonna cause a lot of vibration. Okay, so this one is gonna be these service factors. Okay, on the beta system. And the right hand side, we have two categories anyway. We have the low number of the pinion drive and high number of the pinion drive, things like that. And we have type 1, type 2, and type 3, respectively. Let's see type 1. ICE with hydraulic drive. It's mean, okay? You guys just figure out. See, hydraulic drive mean the motor, the ICE gonna drive the pump, and the pump gonna drive the motor with the fluid motion, things like that. So therefore, the vibration can be just absorbed by the fluid, things like that. So therefore, everything gonna run very smooth, things like that for the electric drive. And then the second one, type 2, is going to electrical motor, and type 3 is gonna be the ICE with mechanical drive, things like that. So okay, again, okay, if you go for the American low number of teeth, we're gonna use the figure 2.13 for the further calculation, and then high number of teeth, you're gonna go for figure 2-14 for the high number of American types of the lower chains. And category 2 is gonna be moderate shock drive, okay, like the fluid and solid mixture, okay. So therefore, everything the same. On the left-hand side is going to be Lolo chains of the British system, and the right-hand side going to be Lolo chains again for the American system. And number three going to be shock, heavy shock load, things like that. So that's why everything's going to be a lot of impact, a lot of vibration, things like that. For instance, like a shaping machine here, okay? So it's going to be some kind of a lot of impact to each other, things like that. Again, the figure here is going to show on the left and on the right. It's going to British and American chain type transmission, okay, respectively. Okay. So let's go for another one. That what we got for. It's gonna be on the chapter 2. Okay, we next step we're gonna do on the number of sprocket teeth. So after we pick up the number of the pin and teeth already, we're gonna pick up the chains, and next we're gonna pick up the sprocket teeth. The things that what available here is gonna be the most commonly used sprocket teeth that what available here in this table. If you decide come close to any values of this, make selection of that anyway. For instance, you go for 75, it's not available, you should make a selection of 76 teeth respectively. And then the next step you're gonna do is the calculation for the collection power. The power is gonna be W sub P times N sub S. N sub S you determine on that already. Okay, so that's why we got the P term there. And this we next step we're gonna make selection of the Lola chains. Okay, we're gonna use the figure 2.12 up to 2.14 based on the selection of the British system and American systems already. Okay, and then after that we're gonna go for the recommendation of the center distance and the corresponding change length anyway. So therefore the pitch, if we design for the pitch of 9.525, we should make a center distance of 450. The reason of this because that's why if you don't believe it, you're gonna of course remember that the force acting on it, you're gonna have some sacking. So therefore, if you go for this, you're gonna minimize the sacking, vibration, things like that. Or if you go for the lower value of this, you're gonna cause a lot of effect difficulties for the tension in the chains too much anyway. Okay. And then let's go for the beta system design. Use the figure 2.12. It be derived this graph from the experiment of 19 teeth. You got one stand, okay, two stand and three stand respectively, and together with the pin and speed, of course, right? So therefore, for instance, like you have a eight, okay, 8 kilowatts, things like that, okay, 8 kilowatts is there, right? You just make a line through that, and then you find the corresponding pin and speed. Okay, it's gonna intersect whatever you want to. Okay, so therefore if you come too close to the normal culture in here, the graph here, you make selection of them anyway. Okay, so this is the things that what you're gonna go for the design. And then for the small number of teeth of the Lolo chains A, okay, we have 4 strands. Then for the selections of that, okay, and then for the American, again for 2.14 we have 4 stand again, and then the number of the sprocket, the number of chains roller. Okay, you use this equation, but you got to round up to be a even number, remember that. So therefore when you round up you got to find the real center distance with this equation. Okay, so this is gonna be the things that what you should, okay, put on the design. Okay, you should put on the design, and then let's go for the design. Okay, the prompt has said like this: a little chain drive transmission comprises of an electrical motor. Okay, driving a speed speed of N1 is 1450 RPM. The power is transmitted to the roller chain and sprocket with a speed ratio of m sub w equal to 2.5. The sprocket shaft is directly connected to a high-speed shaping machine. Okay, so that's why the shaping machine that what I mentioned already is going to be cause a lot of impact, okay, to each other. And given that this transmitted power W sub P equal to 5.5 kilowatts, you got to determine the standard size of the load chain and its corresponding term needed for this transmission system. Okay, first thing first, the driven apparatus is going to be the high speed, right? So therefore, no doubt about it, it's going to be cause a lot of impact. So it's going to be heavy shock load as shown in figure 6.1. No doubt about it. It's recommended you to use a minimum of T's is going to be 23. I make a choice on 23. And then since the apparatus again is going to shaping machine in the categories number 3 is going to be heavy shock load. You make selection of this minimum number of T's of 23 already, and then the electrical motor is going to be given by the palm set. It's going to be smooth drive. If I go for the first choice of the B, as in the figure, as in the table, okay, I gonna get the service factor of 1.45. And then I was stickling to go ahead for the calculation for the next step by using the figure 2.12. Okay, and if I go another way around with the American types, okay, I'm gonna go for either based on the corresponding things that step that what we're gonna do exactly the same that what we've done before. And then it's given by the prompt says aim sub be 2.5. So therefore we got a sprocket number of sprocket teeth is 25 as 57.5. So we just have a look at table 2.4, 2.6. We got C available of 57 teeth respectively. And then we find the collected power is 7.93. So therefore we got two terms, collected power, and N1 is 1450 RPM. Therefore, if we use the graph of 2.12 and we go for the standard belt of B, so that's why the pitch we're gonna make selection based on the graph there of 12.7. Again, based on the table 2.7, okay, we got to go for the British system of the minimum tensile force of 17.85. We have a look at the table 2.4, 2.2, that's characteristics of the standard B term of the minimum tensile force. Now we're gonna check is it proper or not. Okay, if we got the F sub B of 17.85. Okay, first thing first, we find the V term there, and then we find the F sub T, and then we find the F sub CT, and then M there. We use the table 2.1 to find it, and therefore we have F sub CT as the answer. And then the total force is going to be 0.8139. So therefore, if we just compare to the things of the chains can be able to withstand for the the minimum of force that be applied on it is 17.85. So that's why we got a safety factor of 21.93. So this one you got to recognize. This one is gonna be good. Okay, as you concern about the sacking during the motion, it's gonna cause of light vibration, things like that. So therefore, this type of that pick up things that what you should concern with this. And then you got to find the X term there. You make the pitch up to end 12.7 as in table 2.7. You're gonna have a C recommend to be 600. I just plug it in the terms of number of rollers. Okay, I got 135.11. Okay, I can ground it up to be 134 or 136 respectively. I go for 136. So therefore, I plug it for the real center distance at the answer. So I summarize everything in very good manner like that. Okay. So that this can come up with the design of the Lolo chains of 08B, one stand. Okay. And then for 136 dollar, I'm gonna buy it, and then the number of teeth, I'm gonna buy a pinion, okay, with the 23 teeth, and then the sprocket teeth of 57 teeth, and the assembly, everything's at the center distance of 605.7 respectively. This is gonna be the real design that what we're gonna go for it anyway, okay, and then we gonna have some kind of like a prom set. That's what we've got there. So I got prom set number 1, 2, up to 8 there. You're gonna go practice by yourself anyway, okay? And this one is gonna be a very good example and very good practices that what you guys gonna go for it anyway. Okay, it's gonna be it for the lecture of chapter 2. Okay,